feet.
Oh,
I
really?
think. Yeah, and
Oh,
then
wow.
the high power ones can go like line of sight up to like a mile or something
So, but I
crazy.
guess it's contingent on line of sight, which is
Yeah.
slightly
Well,
difficult.
yeah. Well, it's not that difficult if you're like flying your quadcopter in an open field up in the air above you, right?
True, true.
You're gonna have pretty good line of sight to it. In fact, you have to by FAA rules.
Oh,
You
but you have to be able to see
If
it.
you're flying a RC device, plane or helicopter or quadcopter, you have to maintain eye contact between the person controlling it and the
Oh, I see.
that's the rules.
Gotcha. Cool. So, and are you gonna bring? No, Whisker's not bringing anything. He's bringing himself.
Yeah, well, I'm an
And his
ongoing
little knee
project.
pad, his knee laptop thing,
Yes.
the super itty bitty knee,
The little chibi laptop.
Yeah, and if you see a really sexy guy sitting there with a really tiny laptop, that's me.
He's also very modest.
I'm the most modest person there.
Yeah. Right. I hope you guys come up and like hang out with us. Like just take a seat. That's what Don Merch. Yeah, that's what Don Merch did last year. He was sitting there and every time we were there he came by and sat and we chatted and had a great time. So if you guys hear us like and recognize our voices and want to come by and just hang, just pull up a chair. We do not bite. Whisker might, but I'm
Only for comedic effect, however.
Right.
I definitely bite.
And only on Donner's Pass.
Not other people though.
What do you bite then? Oh, food, I suppose.
And my
we should do like a big food fest. Oh, so much fun. There's some good barbecue there.
I bite.
We should have Mel's Diner hamburgers too.
Bites.
Now I'm just distracted.
Bites.
Yes. Which actually, this is a great segue because
I'm good like that.
My question.
You think I may have done this before?
So my question is, do you guys want to talk Propopet or Bite?
I don't care. Whatever you got questions you want to ask about.
Addy?
I guess let's do Bite because I have fewer questions about that than Propopet.
Okay.
And maybe we can get through both of them. Doubtful, but maybe we can.
I doubt it.
All right. Well,
can
we'll
we
try.
say neither? Is that a...
Hey, I like my Propopet. It is very cute and it poos.
I have
a Boolean
been...
question. We could answer with false.
I have been perusing your update of Bite and noticing many
there are errors.
Compile errors.
Oh, yes. I'm not expecting this to compile yet.
She's just writing down her ideas.
All right. So I don't quite remember the last time when we worked on Bite whether or not I had the plus minus times and divide. I did.
You did, but they didn't quite work right, and I gave you the fix of having to put in the EXEP++
right
on each of them because otherwise they wouldn't actually
move on
to the next command.
Right. And then there was also something that I think you said, which was, well, what do you do with register C now? And so that's where I changed some of the symbols, where I did equal leads to the register C being shown in the serial terminal. So that's okay.
Which is kind of interesting just because there was already a way to display a memory thing.
Right, but then I don't know where to...
So it would have been better to maybe write register C to a memory address, and then you could use the command to print the memory address.
But then you would limit where C was.
No, you would expand where C is, because right now C can only be in C, and you have to display C, right? What if you want to display what's in A? Wouldn't it be better to have commands to move the registers into memory, and then you already have a command to display what's in memory, right?
Uh-huh. Yep.
Oh, Bite.
Which is the number.
Bite is going to be the death of me. Truly. Truly. Because my brain's like, what?
Well, the thing is like, what you're...
I get it. I get what you mean. Like, you want to be able to do it so it's psd.dec parentheses, something generic. so that
Well,
any register can be like probably MMP, right?
right. No. What I'm saying is that you already have the number character in byte, which prints out using the deck, PST deck.
Right.
It prints out a memory, whatever's in a current memory address.
Right. But I mean,
So if you, instead of making a command to print out what's in register C, you instead made a command that would put register C in memory somewhere, you could just use the number command to print that out.
The logic behind that is that you are going to need to be able to pull things out of register C. You know you're going to need to do that.
Right.
You don't need 2 ways to print out what's in register C. Because you know you need to be able to pull information out of register C into main memory. And you already have a way to print out whatever you're pointing at in main memory. So therefore you don't need a command to print register C specifically.
So what would you do? Like register C or memp colon equals register C?
Yeah, one command would do that.
Well, not memp. It would be mems with the bracket memp colon equals.
That's what she meant.
Right. Well, and obviously, you need to set your memory pointer before doing that to somewhere in, where it should go. But that's a separate command you can already do by moving the memory pointer around.
Well, that's like 3 commands extra.
Well, no, because you really only need one command extra, which is write register C to the current memory address, because there's already commands to set the memory address.
Memmp will always be the current memory address.
Right. And you already have a command to increment memp and decrement memp.
Right.
So that you can move the memory address around.
He's just talking about which slot in memory you're
I understand
putting
that.
it into, which is
I guess,
related, but not really what
so
we're
then
talking about.
Would I say memp plus 1 colon equals?
No.
Okay. Because, so then in order to do that, I would say...
You had it right the first time.
Yeah, you just
So I assigned the current memory address to be...
To whatever is in the register.
Whatever's in register C.
Yeah.
Okay.
Right.
And then I would do... The next execution would be to print that.
Right. But it would just be the number command, which is a byte command already.
I see.
So whatever the new command is that copies the register into memory, you would have that, and then immediately after it, you could have the number
Why
command.
couldn't I do like right after the register C? So like say the plus sign, right? I have register C colon equals register A plus register B. Couldn't I do on the next line memp colon equals register C?
Well, you could, but you don't. That would be not necessarily a good choice. Like, you don't always want to move a register into memory. You do sometimes, but not always.
Right. Oh,
So
I guess.
it's better to have it be a separate command that
Hmm.
you can choose to do it or not. Right?
Much more flexible and usable that way.
Because what you could do is, as an example, you could have a set of numbers that you do your plus, minus, whatever into register C, and then write register C to a memory address, and then do another, loading of register A and B with new numbers, and do a minus or a multiply, and store that number into a different memory address, and then
So at that point it would be memp plus 1 colon equals.
No.
Oh.
You would move the memory address using the command that moves the memory address.
Oh.
There's already a command to move the memory address to memp plus plus is the greater than symbol, right?
Yeah.
It was. I don't know if Eddie's changed it yet.
No, it still is. I'm looking at the code.
Yeah.
So increment memory pointer is the greater than.
I was tempted to because I wanted to incorporate greater than and less
Yeah,
than.
when you incorporate those mathematical things, you'd probably come up with different characters to represent those commands.
Yeah.
Yeah.
Well,
So,
I actually did. It's one of the new commands that
Right.
I added in. I'll
so
show
one
you.
of the things that you might want to consider doing, just because it might help
Mhm.
for you, is to change some of these commands that were pre-existing that used math symbols
Mhm.
to not use math symbols and instead use some other symbols, like the greater than and less than
Right.
characters, which are incrementing and decrementing the memory address. You might want to change those to something else,
Right.
I and D or something like that. I don't know, which you
Well,
already
We already
we
have.
already
used
have.
I and Z.
You've already
So,
used them, but I
I was
mean
trying to
that
figure
kind
it.
of
Yeah.
thing.
Yeah.
You could come up with
Yeah.
other characters, and that way you can use the math symbols and comparison symbols to be representative of their actual meaning, right?
Okay.
Like you did with plus minus.
Now, is there any
Um,
way to simplify like memory address things? Like, couldn't I just use registers and not even worry about the
Memory is
location
a
of?
register
No, I
with more
understand
than
that.
one slot.
I understand that, but I'm physically incrementing memory pointers in
Right.
the byte host code, right? And I
Right.
feel like that is a very um
It is a cumbersome way to do it.
right.
And the solution
the-
for it is called aliases.
Or another way to solve it, which is something we have been avoiding
Oh.
because Whisker decided it was something to avoid for now, which is right now all of our commands are
Single byte.
one value equals
Yeah.
the command.
Right.
You could have commands that have another byte right after them that
Mhm.
is a piece of data to go
Roy
with the
said, I've been avoiding it. I haven't been avoiding it. I've actually written that version of byte already.
You have.
Well, when I
Yes,
say
it's
it, when I
sitting
say
there ready to
avoiding
go
it-
for when Addy is ready to go.
Right. Oh, I didn't mean that you were avoiding it in that sense. I just meant that
Yeah.
we wanted to bring Addy up to that level first by
It's
doing
avoiding
like-
Addy might be the accurate way
I'm
of
I'm
saying it.
avoiding it.
So the way we could do it is you could have the equals could have equals, and then the next byte is what memory address
Mhm.
to put it into, right?
Okay. Sure.
There could be things like that. But that, like I said, it's a much well, not much different, but it is a different inner loop here that runs the commands because it's got to deal with having extra data with each command instead of just a single character that does everything.
Okay.
And part of the reason that it does it all with the, having to increment the memory pointer one at a time and decrement it one at a time and all that is because it was staying within those strict guidelines of one character per command that
And
does
even
everything.
Right.
when we jump to that, more advanced way of doing things, what you've learned about with pointers
Mhm.
and incrementing and decrementing them around inside of a stack of things,
Mhm.
you will use 1,000 times
Yeah,
into the
it's
future.
still
You will
really
always
valuable.
use this.
Hmm.
It's a really valuable thing to be familiar with.
Okay. Okay.
So,
So-
but do you understand the basic idea that it's better to
Yeah, I get
to
it.
have writing the register to memory and then print out the memory because
Right.
you've already got a command to do that than to make a special command to print the register?
So I would actually, let's see. I would just use. So I would have to make a new command to put register C into mempy.
A memory address, yeah.
Right. Okay. So I understand that because I'm pretty much duplicating what the pound sign does.
Right.
Right. Okay. That's fine. I got it. So I will change that accordingly.
Mhm.
So then the next one was one you guys had wanted me to do in terms of if register A is equal to register B, then register D : equals 1. Else register A equals register B. Register D. Wait.
Yeah, so you've got
Oh.
a bug. The bug there is that you want the not equals instead of equals for the second where it says else.
Well, I could just do else, period, right?
Well, you could do else period. Yeah, you could take off the register equals register.
Yeah.
But you could also do else if register A is less than register B, then register D equals -1, right? You could do more interesting stuff, but that's outside of the scope of this particular command.
Okay, so I just deleted it. I just put else.
So you could just have the else and then
Right.
register
So this
D
is
equals
purely
0.
a comparison of is it equal or is it not?
Right.
Right. The problem now that I had was you guys were saying, well, yeah, now you've got a whole bunch of registers. Well, what are you doing with these registers? So, like register C, I came up with that duplicate thing. But register D, right, which is where if the numbers are equal, then do something. Well, I don't know what I want it to do. So what do you
Right.
do?
Well, the way to think about it, and I think what we were aiming at was for like the way you branch in byte is using the loop construct
Yeah.
or using the jump construct.
So this was
Right.
going to be a conditional thing
Right.
where I would jump to something else.
Right. So what this would be is like when you have the loop construct with the bracket,
Mm-hmm.
it won't do the loop if the memory address right at that's being pointed to when the open bracket occurs
Mm-hmm. Doesn't equal
equals
zero. Right.
If it equals 0, it just skips over the loop to the end,
Right.
right, and executes the next thing after the close bracket.
I see. So I would need to make another command that complements this one.
Right. Well, what you'd
to
want
like,
to
like a
do,
destination point.
well, I think a shorter version of this maybe is instead of writing it to register D,
Yeah.
is that you write it to the current memory address. Because
Okay.
then you could set the memory address to a 1 or a 0, and then when you do the bracket, it will do what's inside the brackets if the
We were
current
still
memory address
baking
is...
this little mechanism when last time we were talking about this. We hadn't quite had it to the point where it was really ready for prime time yet. But yeah, that's a good
Right.
improvement on it.
Oh.
Right. So then you could just have this little tilde command be compare the registers and write the result out to memory.
Oh,
right?
and then
The
I would
current-
Bracket
use
that's existing.
and then the bracket would be
left bracket, right.
right. And then left
Oh.
bracket would do the command inside the brackets, whatever commands are inside the brackets if the registers are equal to each other,
I
and
see.
not do them if they're not equal to each other. So it allows you to do your comparison thing, right? You could load register A with something and load register B with something and then do this command.
So if
And-
register A equals register B, mem P colon equals 1.
Equals 1. Else MP colon equals 0.
Oh, and it comes full circle.
There
Pun
you go.
intended. Ooh.
It is a looping mechanism.
It is a looping mechanism.
Right.
I see. So then I
So,
can get rid of X.
I think you don't need the X or Y commands. I think you were
Right.
trying to figure out what to do with register D there, but
Right.
I don't think you really need those.
Okay, right. And then Y is actually, so then, because we had the increment thingy for the
Uh-huh.
mem pointers, I just used G for greater than, because I was like, well, why not? And
I would do the same thing here also. Instead of writing to a new register, I would write it to the current memory address because you want the same end result, which is doing the bracket or not.
so I actually wouldn't need all these extra registers.
You don't need D or E.
Okay. Mem
A, B, and
P,
C are very useful, however.
Yes.
colon equals 1, else register A is less than register B,
Right.
mem P.
So our listeners should probably go back and review the byte code and our discussions a few episodes ago.
I do
To
not
get
condone
the-
looking too closely at byte code. It is not safe for your health.
No, it's not.
Right, but I mean, at least to know what we've been talking about, to catch up because it's been a while is all.
Should I show the old one too then?
In the description, you could link to the old one that worked and ran your old program, and then show this new one that we're going over.
All right.
Yeah.
Well, cool.
Yeah, you could use G and L I think L is not used, right, for greater
Yeah.
and less than.
But I don't. But
Mm.
that's the thing. The thing about this is the if and the else kind of take two and bring to one. Do you know what I mean?
Yeah, except that you did it again on this one where you have else and then register A less than register B. That's actually not valid code. It has to
No.
be else
Oh,
if you want to have a condition there, but you don't really need that. You can just take away the condition on the else
but I
because
can't because register A could equal register B.
well, right. So then you want else if.
Right.
And then you just the problem there is that you're not going to write anything to memory if they're equal. And so
Oh.
what you need to decide is if you're going to do it in one command, then you
Yeah.
need to decide that equals is either grouped together with greater than or grouped together with less than.
Oh, so I have to separate them.
You if you want it, like I said, you could do it as one command, but then one of the other is going to include equals. So to be less than or equal, and then greater than, or greater than or equal and less than, if they're
Oh.
all one command, because you can only differentiate between greater than, less than, and then equals has to go with one of them.
And I would
Because
definitely
you only
rework the names of the commands here, so that
right,
all the mathematic operators
Matches
are the normal
universal.
mathematic
Yeah.
operators. So
Right.
right.
yeah,
And you just need to change your memory decrement to something else.
Okay.
But so you understand what I'm saying there, where because you have three states as
Right.
a result of that one command, if you want to do it that way,
Yeah.
it's easier because you're only writing out a one or a zero.
Right.
You need it to be only two states, so you
Right.
either have to include the equals in one of them or do it as two separate commands, which one of them is greater than and sets it to one or zero, and the other one is less than and sets it to one or zero.
Okay.
And
Okay.
then you already have one that compares if they're equal, right?
Right.
So you can do that.
Right.
independently,
Interesting.
right?
All right.
And like I said, all of the register E's need to just go to memory, right? Because then you're
Yep.
going to use
I'm
the
gonna
bracket.
I'm gonna delete the register D and the. Oh, I guess I didn't even put register E up there.
Yeah.
Interesting. Okay, so but like at least the commands I added were generic, right?
Yeah.
We'll pick
The
up there.
equals the equals command has the you were printing out register C with the equals command directly,
Right.
and that's kind of like a special case command. And
Right.
if you had continued down that path, you would need to make a command to print out all the other registers as well eventually,
Right.
right? And that's a whole bunch of commands to do that, whereas instead you just need a command to move the register to memory and then you can use it. Because the other thing is you want to be able to save what's in a register off to memory
Mm-hmm.
and be able to use it for other things.
Mm-hmm.
You want to be able to do a math operation and save the result and then maybe use that result with another math operation,
Right.
right? Loading it back up into register A as a parameter for another operation.
Right.
And so it's beneficial to think of that kind of thing where it's going to be useful for multiple things, whereas this is useful for one thing, printing out register C, and that's it.
Right.
and the
That
other
makes sense.
weird one was that you never want to do anything where you're pointing at one spot in memory, and that's where it's getting something, and you're gonna assume that you're gonna drop the result into the next slot in memory.
Right.
Right.
You never want to do
okay.
anything like that.
Yeah, you
Okay.
started to go down that path, and you don't want to do that.
Okay.
That's
All right.
kind of the same problem as when you took all that code and you replaced it with a C, but it's making all sorts of assumptions about
C for cool.
memory. You never want to make assumptions about memory.
Okay.
Right.
All right. I'm getting closer. I'm
Yeah.
slowly understanding.
Yeah,
But-
the idea is to make commands that don't make assumptions about anything other than what they are directly dealing with, right?
I think actually, you know what's easiest for me to understand it? The way that's easiest for me to understand it is by making commands that don't make you repeat in the case of similar situations. As in like it doesn't make you repeat writing the same code, like the same interpreter code over and over again. Does that make sense?
Sort of.
So
sort
like
of, but
Like you said, I would have had to have a whole lot of commands for printing register C, register D, register E. That's repetition. And
Right.
and that's unnecessary repetition, and to get rid of that repetition is to actually, make it more make it work.
To figure out the right combination of commands that accomplishes the same result without
For multiple
having to
things.
repeat the same thing over and over again.
Right.
Yeah. So how about I put it this way for you, Eddie? Say you're asked to design a better way to get newspapers to people's houses on Sunday morning.
Right. I get you.
The obvious solution is, the paper boy. You got a bicycle, right? Bicycle's an easy way to do that job.
Right.
But while engineering the solution, you're looking to engineer the bicycle. You're not looking to engineer a bicycle that actually writes the articles first and puts them into the newspaper and all of that stuff. Just focus on the one little problem.
Okay, yeah.
And that's all you're trying to solve. Because you can have this thing solve the problem of how do you get this to there, and you can have this one say, well, how do I get it in the way that I want it to be before I bring it to there? But they're
modules.
Separate them, you break them apart.
Right.
Make them modular.
Right.
So that's actually, and the next time we talk, I'll be showing you guys my Propopet code, because I feel like in that code, I've learned a lot by trying to decrease the amount of repetition in it. And actually, the Propopet code has like a crap hole of tons of data arrays.
Yeah,
so
it's good practice, that project.
So, yeah.
Now, Addie, I did it last week, and you can do it this week.
Right. What?
There's stuff.
Right. So Toymaker Television is going to be focusing on some super cool.
Addie just makes up phrases. She's not shy about it.
It's Uber School.
Uber School. Yeah, there you go. So cool for school. Uber cool projects that we are going to be focusing our time on. And so we are going to spend a little less time on First Spin and some of our other podcasts, unless, of course, we hear from you guys that you guys want us to continue doing these on a weekly basis. And that's easily done at donate@toymakers.com. Just let us know via that. And, of course, any topics that you'd like us to cover. And, unfortunately, we need funds for some of our projects and to continue doing the weekly shows that we do. We have needs. So if you are willing to help donate to the cause, please do. And we will be more than willing to continue recording, because after all, this is how I learn. This is how I help other noobs like myself learn. And we would love to be doing this more so than,
Yep.
the other stuff.
Yeah. What do you guys want us to focus on? Making money elsewhere or doing this kind of thing? Let us know. Addie, the URL. tymkrs.com/donate.
Yes.
That's the URL for that.
Right.
And I wanted to let you guys know that I'm currently designing a project that's going to be up for sale. A lot of you guys have been fans over the years of some of my projects, and you're always asking me the same thing. How can I get one of these?
Mm-hmm.
Well, I'm designing a kit for one of my synthesizers that's based around the propeller. That's going to be very hackable, and you guys can change it to do all sorts of things that you might find fun or interesting. And we'll have more information up on that, but definitely pay attention to our YouTube channel for more information on that, and also to the audio podcast that we do, patchbay.tv.
Mm-hmm.
Okay, we're out of time for this week. We went over by like a minute or two. Yeah, I don't think you guys mind. We could probably go over for a half hour, and they would be completely satisfied with that.
And we hope that we will see you guys at the expo, because that is the next time we will be talking parallax.
Indeed.
Yeah.
All right. Thank you for listening, everyone. We really, really appreciate it. You can find this show over at firstspin.tv. There's an RSS feed there if you want to have it automatically downloaded whenever we post new ones. That's it for us. See you guys next time.
See ya.
Bye.